Welcome to Vikrant. Myself, Dr. P. Chitterlingappa. Today, we're going to discuss about network layer, transport layer concepts. This is part of the compute networks. So, network layer is mainly deals with routing as well as the logical addressing. These are the two important services are there in this case. Network layer. Some of the features of the network layer is addressing, routing, and packet forwarding, fragmentation, reassembling, quality of service, and some of the protocols are there in this network layer. And we're going to discuss few concepts in this case. So some of the design issues are there in this case. One is the store and forward, packet switching, and services provided to the transport layer, implementation of the connectionless services, implementation of connection-oriented services, and comparison between the virtual circuits and datagram networks. So these are the some of the design issues of the network layer. Delivery of the data packets from the source to the destination across the multiple hops. That is the one of the major concern of the data link layer. So some of the routing algorithms are there in this case. So routing protocol is a routing algorithm that provides the best path from the source to the destination. The best path is the path that has least cost path. So routing protocols are broadly divided into one is the OSPS, OSPF, shortest path first, and the routing protocol, and broader gateway protocol. So routing protocols are routed protocols. Routing protocols are used to process of forwarding the packets from the source to destination. But routed protocols are used to carry user data from the one end system to the another end through the network. Their defined format and structure in the routed protocol. So some of the examples of the routed protocols are IP, IPv4, IP, all the versions, IPv6 and AppleTag. These are the some of the examples of the routed protocol. So this is one analogy of the routing protocols. Routing protocols are broadly divided into two categories. One is the non-adaptive routing protocols, adaptive routing protocols. Non-adaptive routing protocols we can call the static routing protocols. Do not take the routing decisions. Adaptive routing protocols also we can call it as the dynamic routing protocols. So these protocols we take the decisions. So dynamic routing protocols are classified into two. One is the interior gateway protocols and exterior gateway protocols. Again, interior gateway protocols are divided into distance vector, link state, hybrid, and exterior gateway protocols are divided into path vector. And some of the examples of the exterior gateway protocols are BGP, and interior gateway protocols are the RIP, OSPF, AIGR, P, IGRP, ISIS. So these are the some of the protocols are there. So optimality principle. The principle is based on the idea that optimal utilization of the resources in a network achieved when each network node or device selects the best route for the forwarding data. Before we get into the specific algorithm, so it may be helpful to note that one can make a general statement about the optimal routes without regarding to the network topology or topic. This statement we can call it as the optimality. The mainly optimal principle is going to be focusing on, let us assume, there is a one path is there from A to B. There is a one path is there from A to B. If we can add one more node between the path between the AB, which is J. So the sum of the A plus J, J plus B is equal to the sum of the A plus B. That is called as the optimality principle. And shortest path algorithm is there. Shortest path algorithm is the fundamental algorithm used in the computer networks to find the shortest path between the two nodes. The important one is Discussed algorithm is the best example for the shortest path algorithm. The idea is to build a graph of the network with each each node of the graph representing router, and each edge of the graph is going to be representing the communication link or a line. To choose route between the given pair of routers, the shortest this algorithm just finds the shortest path between the graph. So this is the procedure of the shortest path algorithms. First, initially, so we can make it as a, so all the distances are infinity. The starting vertex we can call it as a zero distance, and create a set of unvisited vertices and add all the vertices to it. While set of unvisited vertices is empty, select the unvisited vertex with the smallest distance and mark it as visited for each neighbor of the current vertex that is still unvisited. While all vertices has been visited, the algorithm terminates and shortest path can be reconstructed by the tracing back the path from the destination vertex to the starting vertex using the shortest distance is called as the during the algorithm. So this is one example. So in this example, try to calculate the distance from node A to the node B. And flooding is nothing but the static algorithms. When a packet reaches a router, it is a transport to all the outgoing links except only the link that has reached to the router through. Flooding is used in the routing protocols such as OSPF and peer-to-peer file transfer system such as Usenet, bridging, or these are the some of the examples of the flooding. Let us take. So this is the node. This node is going to be transmitting data to the node B and node C and node D. But and again node B sends this packet to the E and C. B sends packet to the E and C. So node B never sends back to the A. Why? Because the source for this B is A only. That is called as the flooding. And coming to the distance vector, a distance vector routing algorithm operates by having router maintaining the table that is called as a vector. So giving the best known distance to each destination and which link is to get there. These tables are updated by exchanging the information with the neighbors. Eventually, every router knows the best link to the each and every destination. The distance vector routing algorithm is sometimes called by the names of the Bellman-Ford algorithm is also. It was originally from the ARPANET. Bellman-Ford basics. Each router maintains a distance vector table containing the distances between the itself and all possible destination nodes. So this is algorithm for the distance vector routing algorithm. A router transmits its distance vector to each of its neighbors in a routing packet. Each router receives and saves the most recently received distance vector from each of its neighbors. Router recalculates its distance vector when it receives a distance vector from the neighbor containing the different information than before. It discovers that link to neighbor has gone down. The distance vector calculation is based on minimizing the cost to each destination. So this is one scenario given to you. So they are given one network to you. In this network, they are given nodes, which is called as the vector nodes. A, I, H, and K nodes they are given, and they are given delay between the JA, JI, JH, JK, and try to calculate the new routing table for the J. Try to calculate the new routing table for the J. Before that, what we have to do? We know the JA. So we know the J routing table. So we know the J routing table. Try to identify the J's neighbors. So JA is one neighbor, JI is one more neighbor, JH is one more neighbor, JK is one more neighbor. So we know the neighbor distances. We know the JA distance 8, and again JI we know, JH we know, JK we know. So try to calculate the the distance, J distance, and again, so our focus is calculate the new routing table for the node J. So like that, by using these neighbors and a delay, try to calculate the J's new routing table. Next one is link state routing algorithm. So it was a replacement of the link state routing algorithm. Variants of the link state routing is called as the ISIS and OSPF are the some of the examples for the link state routing algorithm. So the idea behind the link state routing is fairly simple and can be stated as the four parts like. Each router is responsible for meeting its neighbors and learning their names. Each router constructs LSP packet which contains the list of the names and cost to reach of each of its neighbors. The LSP is transmitted to all other routers. Each router stores most recently generated LSP from the each router. Each router uses the complete information on the network topology to compute the shortest path route to each of the distance node. This is the algorithm of the link state routing algorithm. And hierarchical routing algorithms. So when hierarchical routing algorithm is mainly divided into some regions, and each and every region is going to be identifying like this. This is very similar to our postal address, a country, state level, districts and villages, and like that we are maintaining some one so hierarchy. So in this case, what we are doing, instead of maintaining the routing table for each and every node, it is very difficult for the complex network. For that purpose, what we are doing, entire network is divided into some regions. This is the region 1 and region 2, region 3, region 4, region 5. So in this case, what happened, so this is called as the routing table for each and every node. So it is very difficult to maintain. Now what we are doing, we are simplifying the routing table. So how can we simplifying the routing table? The region 1 nodes, if you send the data to the node 1A, it is sharing that information to its neighbors. By default, all the information is going to be shared by the all the nodes. So instead of sharing the data to the each and every nodes, try to get only one node's information. Every region we can choose only one node's information, rest of the nodes can share their data easily. Similarly, region 2, region 3, region 4, region 5, so like that we can simplify the nodes. So here node A, 1A, 1A, that is the source, that is the destination. 1B, so 1B, so we can transmit the data via 1A to 1B. So line is 1B, only 1.5 distances. 1C also 1.5 distances. Coming to the 2, region 2, in the region 2 we can transmit the data via node B. Why? Because this is the region 1. Now we are sending the data from 1A node to the remaining nodes. So if you want to send data from the region 1 1A to the region 2 via node B, this is the line. So there are two hops we require. Again for region 3 via node C, we can transmit the data to the region 3. There are two hops. Like that you can maintain the data from in a simplified routing table. Instead of maintaining the each and every nodes routing table, we can maintain only routing table for only respective regions only. And coming to the congestion algorithm, the mainly in the network layer access, the packet delay and loss that degrades the performance. This situation we can call as a congestion. Congestion is nothing but at the same times two or more devices are transmitting the data, automatically there is a congestion may be occur. The network layer, transport layer, both are responsible of the congestion layer. So this is one simple diagram is there in the congestion layer. Actually where your congestion will start. So this is the actual capacity of the network, and whenever congestion is going to be started, automatically it is going to be collapsed. It is going to be collapse. This is the offered load versus good put. Approaches to the congestion control. There are the presence of the congestion means that load is temporarily greater than the resources in the attic. There are two solutions come to in mind. Try to avoid the congestion. We can increase the resources or decrease the load. So this is one analogy is there, different solutions: network provision, traffic aware routing, admission control, traffic throttling, load shedding. So these are the some of the control protocols. We can use these protocols to try to either prevent the congestion or we can react the congestion. So these are the some of the network provisions are there. Quality of service. The quality of service refer to the performance and reliability of network. List of parameters and as well as the policies, and enough capacity for whatever the traffic will be thrown at it. Over provisioning. Less capacity meet application requirements just as well at the lower cost. So these are the some of the issues of the quality of the service. What application need from the network? So how to regulate the traffic that enters the network? How to reserve the resources at routers to guarantee performance? Whether network can safely accept more traffic or that. These are the some of the services of the quality of service. So traffic shaping is also one of the important case. We can regulate the data flow. There are two algorithms are there. One is the leaky bucket and as well as the token bucket. Coming to the network layer is mainly deals with the IP address. This is one small diagram here is there. So how your data is going to be changed from the each and every layer. Each and every layer. So how data is going to be changing. At the data link layer, data should be in the form of frames. Frames. This is the frame. Frame is the collection of trailer, payload, and the header. The maximum unit, the payload size is 500 bytes. And coming to the network layer, so it is only 1480 plus 20 bytes of information, which is called as the packet. Or the transport layer, we can call it as a segment. The size of the segment is 1460 plus 20 bytes. So this is the maximum segment size. Maximum segment size. So internet is divided into two smaller pieces. We can call it as the packets. The transport layer takes the data streams and breaks them up so that they may be sent as the IP packets. They may be sent as the IP packets. There are two versions of the internet protocols are there. One is the IPv4 and IPv6. Internet protocol version 4 is responsible to deliver the packets from the source to the destination. IP4 is a connectionless protocol, uses the packet switch network. Header port and body port or payload contains as the datagram. IPv4 contains datagram which is the header port as well as the body ports are there. So this is the IPv4 header format, version, header length, type of service, total length, identification bits, and don't fragment, and more fragments, time to live protocol, and header checksum, source IP address 32 bits and destination IP address. This is the data. IP address is the address unique numerical identification assigned to every device connected to a computer network that uses the IP protocol, such as the internet. IP addresses are used to facilitate the routing of the data packets between the devices on the network. So here IP addresses are going to be classified into two categories: classful addressing system, classless addressing system. Classful as well as the classless. So IP addresses are the hierarchical, unlike the Ethernet addresses. Each 32-bit address is going to be comprised of the variable length network portion, top of the bits, and host portion of the bottom of the bits. Network portion has the same value for all the hosts on the single network. And in this case, this is called as the IP address format. There are 32 bits are there. The first portion we can call it the network portion and host portion based on the classes. Based on the classes, there are two classes. There are 5 classes are there. So this is called as a class A, class B, class C, class D. So class A begins with the 1 to 127, 128 to 192. So like that, keep on these IP addresses are going to be varying between the class A to class B. So class A, initially the network address is 8 bits and the host address is remaining 24 bits. And class B, 16 bits, 16 bits are network address, remaining 16 bits are. So based on class, the host address, network addresses will change. The range is also will change. And public IP addresses and private IP addresses are there. Public IP address is IP address that can be accessed directly over the internet. And IP address is assigned by the ISP. So your personal devices also as the private IP address that remains so hidden when you connect to the internet through your router's public IP. Private IP address. Private IP address is the IP address your network router is assigned to your device. Each device within the same network is assigned to the unique private IP address, sometimes called as the private network address. So these are the some of the private IP addresses are there. Private IP address are duplicate IP address. The same IP address is available at the different organization. CIDR notations. By using the CIDR notations, classless addressing is also called as the classless interdomain routing protocol. This addressing type helps to allocate the IP address more efficiently. There are some rules are there for the classless addressing. All the IP addresses in the CIDR block must be continuous. The block size should be presentable as the power of the 2. First, IP address of the block must be divisible by the block size. The notation of the CIDR notation is P dot Q dot R dot by slash n. So they are given one CIDR notation here. So this is IP address by slash n, nothing but 22. So what is the meaning of this notation? 27 bits are used for the identification of the network. So this is called as a network. So how many bits are used for the network? So total there are 32 bits are there. In that 32 bits, you can remove 27 bits. Remaining 5 bits are there. So those 5 bits are used for the host address only. So this slash value will represent the number of network bits. Remaining bits are used for the host IP address only. Next one is the subnet. Subnet. The process of dividing single network into the multiple subnets is called as subnetting. The subnetworks so created called as the subnets. Each subnet has its unique network ID address, which is called as a subnet ID. Subnet ID is created by borrowing some bits of information from the host as part of the IP address. Number of bits borrowed depends on the number of subnets you have created. So this is one example is there here. So they are given one IP address. Try to divide this IP address into two subnets. Now what you are doing? 200.1.2.0 is given. Now you to identify, you can divide into two network. This is so host ID. We can borrow one bit from the host ID. That may be 0 or 1. This is called as a subnet ID. the borrowing bits, whatever the bits we are borrowing, that is called as a subnet ID. So you can borrow 0, that is called as the one network, and you can borrow 1, that is called as the another network. So you can divide into two networks. So you can keep 0 with all zeros, this is one network, and you can keep 1 with the all zeros, one more address. So this is the initial address for this subnet. This is also initial address for this subnetwork. For last address, you can keep all ones, automatically you will get. And network address translation is also one of the important things. Actually, what happened? Let us check. So in this case, NATbox is used to converting the public IP address into private IP address, private IP address into public IP address. Because of the scarcity of the public IP addresses, what we are doing, we are using the NATbox. The NATbox or network address translation, the duty is conversion of the public IP address into private IP address, private IP address into public IP address. IPv6, this is also one of the important one. Now everyone is going to be migrating from the IPv4 to the IPv6 because of the scarcity of the IPv4 addresses. So which is the 128 bits addresses. Now what we are doing? So why we are moving for IPv6? For IPv6 larger, so longer address than the IPv4. So this is one silent feature of the IPv6, and second one is the simplification of the header. Third one is the better support for the options, security, quality of service. By observing these parameters, features, we're moving from the IPv4 to the IPv6. So this is the header format of the IPv6 version. Very simple when compared with the IPv4. This is very simple addressing, version, priority, flow label, payload length, next header, and off limit, source IP address, and destination IP address. And internet control protocol, there are three important protocols are there. One is the ICMP protocol, ARP protocol, DHCP protocol. ICMP protocol is nothing but this protocol is used to when something is unexpected occurs during the packet processing at router, the event is reported to the sender by the ICMP packet. During the packet transmission, any packet may be lost, any packet may be stopped somewhere else. That status is going to be represented by using the ICMP protocol. So some of the ICMP messages are there: destination unreachable, time exceeded, and source quench, redirect, echo. So these are the some of the messages are generated by the ICMP protocol. And ARP protocol, address resolution protocol. So internet has one or more IP addresses. These addresses are not sufficient for sending the packets. Data link layer network interface cards such as Ethernet cards do not understand the internet address. In this case, Ethernet, every NIC cards are manufactured comes equipped with the 48-bit Ethernet address. So in this case, so the NIC cards send and receive the frame based on the 48-bit address. They know nothing at all 32-bit IP address. So how do IP addresses get mapped onto the data link layer? That is called as the address resolution protocol. We can map IP address into the MAC address into the IP address by using the ARP or ARP protocols. Dynamic host DHCP protocol. So DHCP protocol in the network must be DHCP server that is responsible for configuration of the newly added device into the network. So try to connect into the any one network. Immediately one IP address is assigned to the your device. That is the duty is DHCP protocol. So this is DHCP protocol, the things. An introduction to the transport layer. Transport layer has the two protocols, the TCP protocol and UDP protocol, connection oriented protocol, connectionless protocol, and so these are the some of the services of the transport layer protocol elements addressing connection establishment, connection release, error control and flow control. Elements of the transport protocol. And congestion control protocol in the transport layer. I'm talking about transport layer. Congestion control, open loop, closed loop, retransmission policy, window policy, acknowledgement policy, discarding policy, admission policy, back pressure, choke packet, implicit signaling and explicit signaling. These are the some of the congestion controls. And performance issues, some of the performance issues are there. Performance problem, measuring network problem, and host design for the fast network and fast segmenting process, and header compression protocols for the long fat networks. This is the header format of the UTP only, source port, destination port, UDP length and UDP checksum is there. These are the some of the ports are there in this layer. FTP, SSH, SMTP, HTTP, POP3, like that some of the protocols are there. TCP. So this is the TCP segment header, source port, destination, sequence number, acknowledgement number, and some of the operations are there. Window size, checksum, urgent pointer. So these are the some of the things. And a TCP connection establishment, which is called as a three-way handshaking protocol. First, you have to establish the connection, get a transmission, and close the connection.